12 men walked on the moon. They planted flags, collected rocks, drove electric buggies across its surface, and when they left, they dropped pieces of their spacecraft onto it, on purpose, to test seismographs. The moon rang like a bell for 55 minutes. Not a dull thud, not a brief tremor, a resonating, sustained, oscillating ring. The kind of sound that only comes from one type of structure, a hollow one. That was 1969. It is now decades later. We still don't have an explanation that fully satisfies the data. This is not a conspiracy video. This is worse. These are facts that passed peer review and still don't add up. The moon rings like a bell. November 20th, 1969. Apollo 12 astronauts Pete Conrad and Alan Bean intentionally crashed the 2.3-ton ascent stage of their lunar module into the moon's surface at 1.7 kilometers per second. The seismographs they'd planted days earlier record the impact. Then the vibrations begin, and they don't stop. On Earth, seismic energy from an equivalent impact would dissipate within seconds, absorbed by water-saturated rock and churning tectonic layers. The moon's vibrations lasted 55 minutes. A later impact test during Apollo 13 triggered oscillations that lasted over 3 hours. 3 hours. Dr. Gordon MacDonald of NASA stated in print in 1962, before any humans set foot on the moon, that the calculated moment of inertia of the moon is best explained by a hollow sphere rather than a solid body. The official explanation: dry, porous regolith with no water to damp vibrations. Plausible, but the acoustic signature of the moon still doesn't match any known geological model for a naturally formed rocky body. It matches something else. And we don't say what that is. 9. The missing audio. NASA lost the original Apollo 11 tapes. Not classified, not encrypted, not secured in a vault. Lost. Approximately 45 reels of magnetic telemetry data, the primary, highest quality recordings of the first moon landing in human history, were officially declared missing in 2006. The agency's explanation, budget cuts in the 1970s, led technicians to degauss and reuse the magnetic tapes for satellite data. The most important recordings in the history of exploration were erased to save money on blank tape. What we call the restored footage today is a 2009 reconstruction assembled from secondary copies, kinescope recordings made by pointing film cameras at monitor screens. A copy of a copy of a copy. Among researchers using the Freedom of Information Act, partial transcripts have surfaced describing communications during EVA sequences that don't appear in the official mission logs. References to lights on the horizon, references to structured objects, none confirmed, none officially denied. What is confirmed, the original evidence is gone. 8. Lunar swirls. The moon has no global magnetic field. Its core is not generating one. The dynamo is dead, and yet, across hundreds of locations on the lunar surface, there are zones of intense localized magnetism, and directly above those zones, Reiner Gamma, Fursov, Gerasimovich, Mare Ingeni, lunar swirls, bright sweeping curvilinear patterns etched across the gray regolith, patterns that look like something moved through the surface, the way a finger moves through ash. Patterns with no topographic relief. No ridges, no valleys, just color. The current best model, these magnetic anomalies deflect solar wind particles, shielding the regolith beneath them from darkening. The bright areas haven't been weathered. The dark areas have. But where did the magnetism come from? Theory 1. Antipodal shock waves from massive meteorite impacts on the opposite side of the moon billions of years ago. Theory 2. Remnant magnetized plasma from ancient comet impacts. Theory 3. Something else entirely that we haven't modeled yet. None of these theories accounts for all observed swirls simultaneously. They share one property. Each one looks deliberate. 7. Transient lunar phenomena. The year is 1540. A monk named Ilchester records an observation of colored lights moving across the surface of the moon. He is not the last. For over 400 years, professional and amateur astronomers have documented what the International Astronomical Union now catalogs as transient lunar phenomena, TLP, flashes, glows, hazes, color shifts, regions of the lunar surface that briefly appear to emit or reflect light differently than their surroundings. In 1968, NASA published Catalog R-277, 579 documented TLP events spanning 4 centuries of independent observation. In 1963, astronomers at Lowell Observatory, the same observatory that discovered Pluto, recorded a vivid red glow over Aristarchus crater. They requested confirmation from observers on other continents. Multiple stations confirmed simultaneously. The European Space Agency has listed Aristarchus as a priority monitoring target for future missions, specifically because of TLP frequency. The accepted explanations: outgassing from subsurface vents, electrostatic dust levitation, solar wind interaction with surface minerals. Each of these is real. None of them fully predicts the frequency, location, and duration of what has been observed. The moon is doing something. We don't know what. 6. The far side. In October 1959, the Soviet probe Luna 3 transmitted the first photographs ever taken of the far side of the moon. Mission scientists stared at the images and thought the camera was broken. The near side of the moon, the face you've seen your entire life, is covered in vast dark volcanic plains called Maria across roughly 30% of its surface. The far side has Maria coverage of less than 2%. The far side crust averages 10 to 15 kilometers thicker. It is older, more cratered, more chaotic. It has almost no large volcanic structures, 2 hemispheres of the same object, and they look like they formed in different solar systems. The leading hypothesis: the early moon collided with a smaller companion body, a second forgotten moon, that smeared itself across the far side, thickening the crust and burying the volcanic regions. This hypothesis has a name: the Big Splat. It is not proven. The gravitational, chemical, and geological data doesn't fully align with it. We are currently working on explaining why one side of our nearest neighbor in space looks completely different from the other. We don't have the answer. 5. Moonquakes. The moon should be geologically dead. No plate tectonics, no substantial liquid mantle, no volcanism, or almost none. The seismographs left by Apollo missions 12 through 16 recorded thousands of moonquakes over the 8 years they remained operational. 4 categories: deep moonquakes, originating 700 kilometers below the surface, deeper than any earthquake ever recorded on Earth. Shallow moonquakes, violent, unpredictable, poorly understood. Thermal quakes caused by extreme temperature swings between lunar day and night, and meteorite impacts. The deep moonquakes occur in clusters triggered with clockwork precision every 27 days, the exact orbital period of the moon around Earth. Tidal stress from Earth's gravity is flexing the lunar interior on a monthly cycle, which means the interior of the moon is not the cold, rigid, inert mass our models assumed. Some shallow moonquakes registered magnitude 5.5 on a scale adjusted for lunar conditions, strong enough to damage structures. Duration: up to 10 minutes. A magnitude 7 earthquake on Earth lasts 2 minutes. The moon shook for 10. 4. Orange soil, December 11th, 1972. The last day of the last human mission to the moon in all of history. Geologist astronaut Harrison Schmitt, the only professional scientist to stand on the moon, brushes back the surface layer at the rim of Shorty Crater and stops. "There's orange soil," he shouts. Commander Gene Cernan assumes he's joking. Then he sees it. Bright orange volcanic glass beads, 3.64 billion years old, erupted from a fire fountain when the moon was still actively volcanic. The beads are rich in iron, zinc, sulfur, and lead. Individually, they're explicable, but the concentration of volatile elements locked inside them is anomalously high, far higher than any standard model of lunar mantle cooling predicts. The moon locked chemistry inside those beads that shouldn't have survived the cooling process. 30 years of analysis. No consensus on the formation mechanism. The last thing we found on the moon before we stopped going was something we still can't explain. 3. Tycho crater lights. Tycho crater. Diameter 85 kilometers. Depth 4.5 kilometers. Age approximately 108 million years old. Young by lunar standards. For decades, Tycho has been one of the most active zones for transient lunar phenomena. In the 1950s, reports began accumulating of brilliant flashes observed within the crater. Flashes visible through amateur telescopes from Earth, confirmed by multiple observers, on multiple nights, across multiple decades. The brightest recorded TLP events in the IAU catalog cluster around Tycho with unusual frequency. Proposed mechanisms: piezoelectric discharge from stressed crystalline rock, meteorite micro-impacts generating localized plasma, radon gas, outgassing reacting with solar UV. Each mechanism works in isolation. None accounts for the spatial consistency. Why Tycho specifically, again and again and again? The crater is also home to a geometric central peak, a mountain that rose from the impact melt with near-perfect symmetry, a natural formation, almost certainly. 2. The perfect eclipse. The Sun is 1,392,700 kilometers in diameter. The Moon is 3,474 kilometers in diameter. The Sun is approximately 400 times larger than the Moon. The Sun is approximately 400 times farther from Earth than the Moon. During a total solar eclipse, the Moon covers the solar disk with precision measured in fractions of a percent, leaving only the corona visible, like a ring of fire around a perfect black circle. No other moon of any other planet in the solar system produces a geometrically precise eclipse like this. Not one. Jupiter has 95 moons. Saturn has 146. None of them produce a perfect occultation of their parent star as seen from their planet's surface. Physicists call this the anthropic coincidence, a quirk of geometry that serves no physical purpose and arose presumably by chance. The probability of two bodies in a randomly formed system sharing this exact size-to-distance ratio is vanishingly small. There is no scientific theory that requires this to be true. There is no evolutionary pressure that would select for it. It is simply, exactly correct. 1. The objects. This is not a theory. These are official transcripts. During the Apollo 11 mission, Neil Armstrong and Buzz Aldrin reported observing an object at distance that they could not immediately identify. The official explanation: the SLA panel adapter, a component of the spacecraft that had separated earlier in flight. Plausible, documented, accepted. But the transcripts don't stop there. In sessions obtained through the Freedom of Information Act, crew members across multiple Apollo missions describe lights above the lunar horizon, flashes originating inside craters, and structures. That word appears in raw transcripts, structures that the crew cannot classify using their equipment or their training. Some of these transcripts remain in restricted access to this day, with no declassification timeline provided and no official explanation for the restriction. Edgar Mitchell, lunar module pilot of Apollo 14, the sixth human to walk on the Moon, holder of a doctorate in aeronautics from MIT, stated publicly until his death in 2016 that unexplained phenomena observed during Apollo missions were systematic, not isolated, and that the institutional response to crew reports was to classify and suppress rather than investigate. NASA did not refute his statements. NASA did not confirm them. They issued no response at all. The Moon is 384,400 kilometers away. We can see it with the naked eye. We have been there. We have instruments on its surface. We have hundreds of kilograms of its material locked in laboratories on Earth. And it is still sending us questions we don't know how to answer. The nearest thing in space is the least understood. Subscribe. The next one goes somewhere darker.